sequence. A sequence is a function whose domain is the set of positive integers. It also means an ordered list of numbers. A sequence is infinite if its domain is the set of positive integers without a last term, such as 1, 2, 3, 4, 5, and so on. The three dots show that the sequence goes on indefinitely. A sequence is finite if its domain is the set of positive integers such as 1, 2, 3, 4, 5, which has a last term n. Examples. Letter A. 1, 2, 3, 4, 5, 6, 7 is an example of finite because it doesn't have three dots at the last digit of number. The second one, which is letter B, has 3, 6, 8, 12, 15, which has three dots. So this is an example of infinite because it has a three dots at the last digit of number. So how to solve this? Examples. First is determine the first four terms of the sequence whose nth term is given by the formula a sub n is equals to 5n minus 2. The first example that I will be solving is to find the first four terms of the given formula, which is a sub n is equals to 5n minus 2. So, first, let us identify the formula. So, the given formula is a sub n is equals to 5n minus 2, where a sub n represents the nth term of the sequence. So, to find the first term, let us substitute n is equals to 1. So, let us substitute the value of our n, which is 1. So, a sub 1 is equals to 5 times 1 minus 2. So, as you can see, I substitute the value of our n, which is 1. So, 5 times 1 is 5 minus 2. So, 5 minus 2 is 3. So, the value of our first term is equals to 3. To find the second term, let us substitute n is equals to 2. So, let us use the same formula, which is a sub n is equals to 5n minus 2. So, a sub 2 is equals to 5 times 2 minus 2. So, just the same, I'd substitute the value of our n, which is 2, into the formula. So, 5 times 10 is 5 times 2 is equals to 10. So, 10 minus 2 is equals to 8. So, the value of our second term is 8. And then, to find the third term, let us substitute the value of our n, which is 3, into the same formula. So, a sub n is equals to 5n minus 2. So, let us substitute the value of our n. So, a sub 3 is equals to 5 times the value of our n, which is 3, minus 2. So, 5 times 3 is equals to 15. So, 15 minus 2 is equals to 13. So, the value of our third term is 13. And to find the fourth term, let us substitute the value of our n, which is 4, into the formula. So, a sub n is equals to 5n minus 2. So let us substitute the value of our n, which is 4. So a sub 4 is equals to 5 and times the value of n, which is 4, minus 2. So as you can see, I'd substitute the value of our n here. So 5 times 4 is 20. Minus 2. So 20 minus 2 is equals to 18. So the value of our fourth term is 18. So the first 4 terms of the sequence are 3, 8, 13, and 18. Second example. Determine the first 3 terms of the sequence whose nth term is given by the formula a sub n is equals to 3n squared plus 2n squared over n. So for the second example, the given formula is a sub n is equals to 3n squared plus 2n squared over n. So to find our first term, let us substitute the value of n into the formula, which is 1. So n is equals to 1. So let us solve it now. So a sub n, so let us substitute the value of our n, which is 1 here, is equals to 3n. So let us substitute the value of our n. 3 times 1 raised to the power of 2 plus 2n. Let us substitute the value of our n again, which is 1 raised to the power of 2 over n, or over 1. So let us copy the 3 here. 3. So 1 times 1 is 1 plus, let us copy the 2, and then 1 times 1 is 1 also. So over 1. So 3 times 1 is 3 plus 2 times 1 is 2. So over 1. 3 plus 1 is equals to 5 over 1. So since we can simplify this fraction, so let us simplify it. So it is just easy. So 5 divided by 1 is equals to 5. So the value of our first term is 5. But if the result became a fraction that cannot be simplified, all you need to do is just to copy the fraction. For instance, the result is 3 over 2. Since 3 over 2 cannot be simplified, therefore you will just copy it and it will be the final answer. So since this fraction cannot be simplified, all you need to do is just to copy it. Okay? To find the second term, let us substitute n is equals to 2 into the formula. So using the same formula, let us solve for the second term. So a sub n is equals to 3n squared plus 2n squared over n. So, let us substitute this n into 2. So, a sub 2 is equals to 3 times 2, because our n is 2, raised to the power of 2, plus 2 times the value of our n, which is 2, and then raised to 2 over 2. Okay? And now, let us copy the 3 here. And then, 2 times 2 is 4. Plus 2. Let us still copy this. And then, 2 times 2 is 4 also. So, over 2. So, 3 times 4 is 12. Plus 2 times 4 is 8. So, over 2. So, 12 plus 8 is 20 over 2. So, since we can simplify this fraction, let us simplify it. So, 20 divided by 2 is 10. So, the value of our second term is 10. So, that is the value of our second term. And now, let us proceed in solving for the value of our third term. So, to find the value of our third term, let us substitute n is equals to 3. So, we will just use the same procedure as what did I used in solving these first two terms. So, we will use the same procedure as what I used in solving these first two terms, so using the same formula. So, a sub n is equals to 3n squared plus 2n raised to 2 over n. So, let us substitute the value of our n, which is 3, into the formula. So, a sub 3 is equals to 3. So, the value of our n is 3 raised to 2 plus 2, and the value of our n is 3 raised to 2 over the value of our n, which is 3. So, let us copy the 3 here. So, 3, and then 3 times 3 is 9. Plus, let us copy this 2, and then 3 times 3 is also 9 over 3. So, 3 times 9 is 27. Plus 2 times 9 is 18 over 3. So, 27 plus 18 is equals to 45 over, let us copy the 3, over 3. So, as you can see, we can simplify this fraction. So, let us simplify. So, 45 divided by 3 is 15. So, a sub 3, or so our third term is 15. Therefore, the first three terms of the sequence are 5, therefore, the first three terms of the sequence are 5, 10, and 15. The four types of sequence. First is the arithmetic sequence. Arithmetic sequence is a sequence in which each term is obtained by adding a constant called the common difference to the previous term. For example, 2, 5, 8, 11, and etc., where the common difference is 3. Second is the geometric sequence. Geometric sequence is a sequence where each term is obtained by multiplying the previous term by a constant called the common ratio. For example, 3, 6, 12, 24, and etc., where the common ratio is 2. Third is the Fibonacci sequence. A Fibonacci sequence is a specific sequence where each term is the sum of the two preceding ones, usually starting with 0 and 1. For example, 0, 1, 1, 2, 3, 5, 8, 13, and so on. And the fourth is the harmonic sequence. Harmonic sequence is a sequence formed by taking the reciprocals of an arithmetic sequence. For example, 1, 1/2, 1/3, 1/4, and so on, represents a harmonic sequence derived from the arithmetic sequence 1, 2, 3, 4, and so on. Yes, there are four different types of a sequence, but here on our topic, we will only focus on two types of sequence, which are the arithmetic sequence, which will be discussed by Mr. Adige, and the geometric sequence, which will be discussed by Miss Jisoyot.
Now we already know what is sequence. And now, let us know what is series. Series is the sum of the terms of a sequence, which can include numbers or functions. For example, in a sequence 1, 4, 9, 16, 25, if we put that into a series, or if we want to know the sum, we will have to change the sign or the comma sign of the sequence into plus sign. And it will be read as 1 plus 4 plus 9 plus 16 plus 25 is equals to 55. There are also types of series, the finite series and the infinite series. Finite series is a series that has a definite number of terms, meaning it has an exact beginning and an exact end. For example, in letter A, 2 plus 4 plus 6 plus 8, this has 4 terms. In letter B, 1 plus 1 plus 2 plus 3 plus 5 plus 8, this one has 6 terms. An infinite series is a series that continues without an end. Unlike a finite series that has a specific number of terms, an infinite series goes on forever. It never stops adding numbers. We usually show this using the three dots called an ellipsis, which means the pattern keeps going. For example, in letter A, 2 plus 4 plus 6 plus 8 plus 16 plus 32, and so on. In letter B, 1 plus 1 plus 2 plus 3 plus 5 plus 8, and it continues endlessly. So remember, if a series never ends and keeps on repeating its pattern, it's called an infinite series. Partial sum, denoted as a sub n, represents the sum of the first n terms of a sequence. This means we add up each other starting from the first e sub 1, then e sub 2, e sub 3, and so on, until we reach the nth term or e sub n. So we can write it as e sub n equals e sub 1 plus e sub 2 plus e sub 3 and continues until e sub n. In simple terms, the partial sum helps us find the total of the first few terms in any sequence. In the given sequence 1, 3, 5, 7, 9, we are finding the partial sum of the first three terms, written as e sub 3. This means we add up the first term, second term, and the third term of the sequence, which is e sub 3 is equals to 1 plus 3 plus 5 is equals to 9. It is important we know what is the first term, second term, and third term in a sequence to avoid mistakes. Example number 1. Find the sum of the sequence 5, 10, 20, 40, and 80. As I said, if we want to know the series, we have to change the comma sign of the sequence. So it will now become 5 plus 10 plus 20 plus 40 plus 80. So it will now become a sub 5 is equals to 5 plus 10 plus 20 plus 40 plus 80. So our S sub 5 is 155. In example number 2, in the sequence 3, 7, 11, 15, 19, 23, we have to find the sum of the first 4 terms. And remember, in finding series, we have to change the comma sign of the sequence into plus sign. So our solution will be e sub 4 is equals 3 plus 7 plus 11 plus 15. And our a sub 4 or our sum is equals to 36. And that's all. And always remember that series is the sum of the sequence of a term, and remember to change the comma sign into plus sign if it's a series.
Good day, everyone. Today, I'll be sharing something we often see in your life: arithmetic sequence. These are patterns of numbers that increase or decrease by the same amount each time. From saving money regularly to noticing patterns in designs or schedules, arithmetic sequences are everywhere. But before we learn what is arithmetic sequence, let us know first what are our goals before learning arithmetic sequence. Now, I'll discuss to you all what are our goals in arithmetic sequence. So, our goal or learning goal is that first, define and identify an arithmetic sequence. Second, determine the common difference, nth term, and recursive formula of an arithmetic sequence. Third is compute the sum of the first n terms in an arithmetic sequence using appropriate formulas. Now, I'll be discussing or explaining what is arithmetic sequence. So, let us go now on the next page or slide. So, arithmetic sequence was already taught in grade 10, but it doesn't mean it's still the same because we are now in senior high school. In grade 10, it just have taught us basic things so that we can understand it in senior high school. Now, in senior high school, we are understanding arithmetic sequence deeper and harder or more complex. So now, let us define what is arithmetic sequence. Arithmetic sequence is a pattern of numbers that have the same number added to get to the next term. This number is the common difference, or CD. So in arithmetic sequence, it's all about adding a number in the preceding term to get the succeeding term. So when we add that number, it is called the common difference or CD. Basically, common difference means what they have in similar. Simply, it is how much you add to get the succeeding term. of that given. So we have an examples of an arithmetic sequence. First is 3, 5, 7, 9, 11, 13. And the second one is 16, 20, 24, 28, 32, 36. And the third one is 10, 15, 20, 25, 30, 35. So do you know what is our common difference in these examples? If not, then I'll show you how to get our common difference. So these were the three examples that were given, and we will find the common difference. First is 3, 5, 7, 9, 11, 13. Our ace of 1 is 3. Our ace of 2 is 5. Our ace of 3 is 7. Our ace of 4 is 9. Our ace of 5 is 11. And our ace of 6 is 13. So in solving our common difference, we can just subtract ace of 2 to ace of 1. So our ace of 2 was 5. And our ace of 1 is 3. So ace of 2 minus ace of 1 will be our common difference. Ace of 2 minus ace of 1 is equals to our CD, or common difference. Now let's substitute it. 5 minus 3 is equal to 2. So 2 is our common difference in the example that we're given. Now let's go to the second one. So the second example is 16, 20, 24, 28, 32, 36. So we have already know how to find our CD. It was ace of 2 minus ace of 1. So our ace of 2 was 20. And our ace of 1 is 16. So 20 minus 16 is equal to 4. Then 4 is our common difference. It's actually easy to find our common difference in these examples, because we will just subtract it to the preceding term. Now, let's answer number 3. So number 3 is 10, 15, 20, 25, 30, 35. So let's subtract our ace of 2 to ace of 1. So 15 minus 10 is equal to 5. Then 5 will be our common difference. Now let's check our answer, if it's right. So in number 2, 16, and let's add our common difference, which we have now been solved. So our common difference in number 2 is 4. So 16 plus 4 is equal to 20. And now let's solve number 3. So 10 plus 5 is equal to 15. The 5 was our common difference. So now let's go to the other topic, or another topic. Now, I'll be teaching the formula for determining the nth term in an arithmetic sequence. So the formula is a of n is equal to a of 1 plus quantity of n minus 1 d, where a of n is the nth term, and a of 1 is the first term, and d is the common difference, and n the term number. So basically, a of n represent the value of the nth term, meaning the specific number of what we want to find at the nth term position in the sequence. And a of n is the first term of the number, as I just have said there. So it is the starting number in the arithmetic sequence or in a given arithmetic sequence. And d is the common difference is the number we will be adding in the preceding or previous term so that we can get the succeeding term or the next term. And n is which term or position you're referring to in the sequence. Example, you're referring to the third term in an arithmetic sequence or the fifth term. That's an example of the nth term. So now, we will be having an example in which we will be using the formula for determining the nth term in an arithmetic sequence.
Good day. Today I'm going to discuss about the geometric sequence. First, what is geometric sequence? Geometric sequence is a sequence whose term after the first term is obtained by multiplying a constant number to the preceding term. The constant number is called the common ratio. So, ibig sabihin, ang geometric sequence ay isang uri ng sequence ng mga numero kung saan ang bawat termino ay nakukuha sa pamamagitan ng pagpaparami ng naunang termino sa isang konstantong tinatawag na common ratio. And here's the formula for finding the nth term in geometric sequence. A sub n is equal to a sub 1 times r raised to the power of n minus 1, where a sub n is the nth term and a sub 1 is the first term, r is the common ratio, and the n is term number. And now we're going to proceed the examples. First example is determine the sixth term of the geometric sequence whose first term is 7 and whose common ratio is 2. And now we're going to solve it by using the formula a sub n is equal to first term times r raised to the power of n minus 1. So our given are a sub 1 is equal to 7, or our first term is equal to 7, r is equal to 2, and is equal to 6. And first we're going to solve it. So it will be a sub 6 is equal to 7 times 2 raised to the power of 6 minus 1. And copy the 7 times 2, 6 minus 1 is equal to 5. So it will be 7 times 2 raised to the power of 5 is equal to 32. Then 7 times 32 is equal to 224. So our sixth terms is equal to 224. Let's move on to second example, which is find the nth term of the sequence 3, 12, 48, and so on. And our number 2, we're going to use the formula again. A sub n is equal to first term times r raised to the power of n minus 1. And we have also a given, which is first term is equal to 3, r is equal to 4, and n is equal to 8. So we're going to substitute it again, and it will be a sub 8 is equal to 3 times 4 raised to the power of 8 minus 1. Copy the 3 times 4, and 8 minus 1 is equal to 7. Then 3 times 4 raised to the power of 7 is equal to 16,384. 3 times 16,384 is equal to 49,152. So our eighth term is equal to 49,152.
Hello everyone, I'm Anjali B. Kuliko, and in this video, I explain what geometric series is, including both infinite and finite type. So, what is geometric series? A geometric series is simply the result of adding up the terms of geometric sequence. Each term in the sequence is multiplied by the same number, which we call the common ratio. For a finite geometric series or a series with a fixed number of terms, we use this formula S sub n equals a sub 1 multiplied by the quantity of 1 minus r raised to n over 1 minus r, where a sub n is the sum of the first n terms, a sub 1 is equals to the first term, r is the common ratio, and n is the number of terms.
Now, we'll proceed to example number 1. Find the sum of the first 8 terms of the given sequence 4, 12, 36, and 108. To solve for the first 8 terms, we're going to use the formula S of n equals a sub 1 multiplied by the quantity of 1 minus r. Our r is the common ratio, and our n is the number of terms, over 1 minus r. So let's start using this formula for us to solve the first 8 terms. So this will be S of 8 because we are finding the first 8 terms of this sequence. So our A sub 1 is 4. And now 1 minus, for us to solve our common ratio is simply we just divide the second term by the first term. So 12 divided by 4 is 3. So our common ratio is 3 raised to 8 because our number of terms in that problem is 8. So 1 minus r. So 4 is the second. So 1 minus 3 raised to 8 is 6,561 over 1 minus r or 3 is 1 minus 3 equals 4. So 1 minus 6,561 is negative 6,560 over negative 2. Because 1 minus 3 is negative 2. So let's divide it. Negative 6,560 divided by negative 2 will be positive 3,280. So let's multiply 4 times 3,280 is equals to 13,210. So our S of 8 is 13,204. Therefore, the sum of the first 8 terms of the given sequence 4, 12, 36, 108 is 13,210.
When a geometric series goes on forever, we call it an infinite geometric series. If the ratio's absolute value is less than 1, the terms keep getting smaller, and we can find its sum using S sub infinity is equals to a sub 1 over 1 minus r.
We have here example number 1. Find the sum of the infinite geometric sequence 27, 9, 3, and 1/3. For us to solve for the sum of infinite geometric series, we are going to use the formula S sub infinity over a sub 1, where our a sub 1 is our first term, over 1 minus r, and our r is the common ratio. So let's start to solve. So S sub infinity is equals to our first term is 27 over 1 minus our r. To solve for our r, we just simply divide our second term, which is 9, divided by the first term, which is 27. So our r is 1/3. Let's put it here, 1/3. So S of infinity is is equals to 27 over 1 minus 1/3 is 2/3. So 27 divided by 2/3 is 81 over 2 or 40.5. Therefore, the sum of the infinite geometric sequence 27, 9, 3, and 1/3 is 81 over 2 or 40.5.
To summarize, geometric series adds the terms of geometric sequence. We have the formula for finite series and another one for infinite series. That's all. Thank you for listening, and I hope you learned something.
And now we will discuss about binomial theorem. Binomial is a polynomial that has two terms. It is also the sum of the difference of two terms. So we have here examples. These are all binomial expressions. You will be familiar already with the need to expand brackets with squaring such quantities. You will know, for example, that quantity of x plus 1 squared, when we factor out, it will be quantity of x plus 1 times quantity of x plus 1. Then we will use file method. So x times x is equal to x squared. X times 1 is equals to x, and x times 1 is equals to x, and 1 times 1 is 1. So we will gonna add, so x squared remain, and x plus x is equals to 2x and plus 1. We have 5 observations. The first one, the number of terms in the expansion quantity of x plus y is raised to the power of n is n plus 1. Second, the expansion begins with x raised to the power of n and ends with y raised to the power of n. Third observation, the exponents of x decreases by 1 each successive term, and the exponents of y in any term that after the first is 1 greater than the exponent of in the preceding term. Fourth, the sum of the exponents of the variable x and y is equal to n. For the last observation, we have the coefficients are symmetric. They increase at the beginning and decrease at the end of the expansion. If you want to raise a binomial expression to a power higher than 2, it is very cumbersome to do this by repeatedly multiplying x plus 1 by itself. In this unit, you will learn how to triangular pattern of numbers known as Pascal's triangle can be used to obtain the required results very quickly. So, we also have here the formula of binomial theorem. Let's have an example. Use the binomial expansion formula to expand the following quantity of x plus 2 cubed, where a is equal to x and our b is 2 and our n is 3. In solving, let us substitute by using the formula. In solving inside the quantity, you just put in calculator 3 shift divide by 0. Simplify and then you will get the answer. As you can see, the x is decreases. Now let's move by finding a particular term in binomial expansion. For example, find the fifth term of the expansion of 1 to 2 of x plus 2 raised to the power of n, where a is equal to x, b is equal to 2, n is equal to 8, and r is equal to 5. For solving, we were gonna use or substitute using the formula. Then we were gonna simplify 8 shift 4 is equal to 70, x raised to the power of 4, copy, then 2 raised to the power of 4 is equal to 16. 70 times 16 is equal to 1120, then x raised to the power of 4, copy, and that's all, we get the final answer. Therefore, the fifth term is 1120 x raised to the power of 4. That's all.